Okay, let me make sure this is recording. So today we're going to go over MongoDB, which is a NoSQL database, meaning that it's not a typical relational database like you would see with something like SQL. Entries aren't stored in tables, they're stored as what are called documents. Basically, it operates as what's called a document store. The documents that MongoDB stores are very much like JSON objects. And whenever we collect them, they don't have to be all uniform. They don't have to all have the same schema. We can just sort of have like a grab bag of objects, which can be good and which can be bad. Well, at least confusing. You can have schemas, but by default they're not enabled. So for future work, whenever you're wanting to work with Mongo, there's a free download and installation for it. The link's here. There's downloads for pretty much every distribution of every operating system. If you just want to work locally, there are also some cloud-based free versions of it if you want to work with that instead. I don't have a lot of experience right now with those, so you might be on your own if you go down that path. All right, so just to give you a quick overview of what a Mongo database server looks like. So generally, Mongo runs on a server, which can have multiple databases contained within that server. Each of those databases can have many collections, which are just collections of documents, of entries. And then each of those documents is JSON-like. And so typically whenever you run a query like you would with SQL or something like that, it's done on a collection. And so you typically look for documents or add documents to collections and run queries and different types of things on a single collection. This is just an example of what an arbitrary document could look like inside of a Mongo collection. As I pointed out, it looks very much like JSON. And you have it's represented with these curly brackets around key value pairs. You can have sub objects or documents within objects, and that can go as deep as you want it to. Typically, the only thing that's required will be this ID field, which is the special object type here, which is going to be unique between all of the objects within a collection, or all the documents within a collection. There is some data that's actually encoded in here, I believe. I believe the timestamp that the object was created is encoded in the object ID, but don't quote me on that. But yeah, so it's very much like JSON, which makes it easy to get data in and out of Mongo and into our JavaScript applications. So yeah, the data that is actually being stored in what's called BSON, which I believe stands for like binary structure object notation or something like that. It's a binary data serialization that is very similar to JavaScript in structure. It is a little bit more typed than JSON is. So JavaScript, we have things like just number or string. There's a little bit finer grained typing with JSON. You have things like doubles versus integers. We have objects. We have binary data, different timestamps. You can actually there's actually a type for having JavaScript inside of JSON or inside of a BSON object. So you can have some interesting data in there. However, a lot of the things that we're going to use have easy utilities for transferring data to and from JSON or JavaScript and BSON. So it's pretty easy to work with. All right, what's next? Okay, so we're going to go over the CRUD operations of Mongo, which people seen the acronym CRUD before? Okay, so it stands for create, remove, update, and, or no, create, why am I blanking what R is? Read, sorry, yeah, create, read, update, and delete, sorry. So this first one is create. So if we want to add an object to, or a document to one of our collections, we just call this insert one. And all of this notation is what you would do from like the Mongo command line, which I'm going to demo here in a little bit. So even the notation for the Mongo command line is very JavaScripty. So we have our database, we have the collection users, and then we call insert one to insert this new document. This document is simply noted as this object where we have these field value pairs, name to age 26, status pending, and that just goes right into our collection. So that's pretty straightforward. If we want to find something out of that collection, basically this is the function that you would use for doing a query, like a select query from SQL. So we call .find on a collection, and we specify some parameters here for our query. In this case, we would be searching for anyone with an age that's greater than 18. You can make this as complicated as you want it to be. There's a lot of documentation on how to do that in the places that I link in here for whenever you're working with it. But we can also do projection. So if we don't want to include all of the values of the documents that we're finding, we can just specify a subset. So in this case, we would be specifying that we want to see name and address, but we wouldn't necessarily want to see age or other pieces of data that would be in these documents.
What you should want then?
Sorry?
You have to want the name is one. Is that in the first?
So that's basically the one is basically a true instead of 0, which would be false, I think. And then yeah, for these you can also have these operations which specify like how much data you get back, what page of data you get back. So if you have a database with 1 million entries and you're running a query on it, you might not want the database to send you all 1 million entries. You can get some small number of them and then page through them potentially using modifiers like this. So this is update. So again, this is like find, and now we have a filter like for our query. However, instead of just finding, we're changing the documents that match this query. So we're setting setting a particular property status to reject for anybody that matches, for any document that matches this query. Pretty simple. And then delete many, which has this would be the query again, and we would just delete any object that would match this filter. So there are some variations of these operations that you can look up, but these are the basic ones. There's some slight variations between like insert one, insert many, yada yada, just variations in semantics. Okay, and I guess I could have skipped past some like baseline database things. Have people in here taken the database class that is offered,
In progress.
that's in progress, that Parth teaches? Can I just see a show of hands just so I know, like, the coverage? Okay, so the coverage is pretty good, actually. So those of you know that databases are applications that we use for storing data and that we use for processing and retrieving data. Typically, one of the most common applications for using databases is in conjunction with web applications. We use it for storing data that go along with our applications, things like users, things like their histories, their purchase records, documents, these kinds of things. So that's why these are useful. And I wanted to cover Mongo just because it's a different flavor than SQL, and it's sort of like one of the newer database applications that's being used with web applications right now. Is there any questions about Mongo in general at this point? I'm going to do a quick demo with command line, just showing you how you can work with it. Okay. After that, I'm going to show how you can work with it in Node.js. All right. So, and as I mentioned before, you can just go here and install what's called the Community Edition of Mongo on your local computer. It takes 5 or 10 minutes, so I'm not going to do it right now. I've already done it. But once it's running, it on your computer, it basically runs as a background service, which your applications can connect to. And the main way that there's a couple different ways that you can actually manage it and manipulate it. The most ubiquitous one is going to be the command line. So I'm just going to say exit. So my experience is that the installation doesn't put the Mongo client into the path for your terminal. So you can either manually do that, or you can just go to the Mongo bin directory right down here. The Mongo client is just simply Mongo. You press enter. This will connect to your database. You get some output here. I haven't set up like access control or anything like that, which you would want to do in a production server. So right now it's like anything can connect to the server and mess with it. If you're running in production, you'd want like passwords and other kinds of access controls so that your malicious actors couldn't connect to your database. But also, if you're running Mongo on a separate computer, what would often be right here after the command will be the URL for your server, which would be like an IP address and port number like this. So this is just the default, which is this local IP address plus the 27017 port, which is the default port for Mongo. This URL could potentially have a username and password depending on what you have set up in your environment. But that's all details that you can look up and figure out. All right. So basically, it's just a terminal that has some special commands. There is fairly useful help. So if I just type help, it'll list out some of the basic ones that I can do. So some simple ones, I can do show DBs to show the databases that I have. So right now, these are the default ones, which Mongo self-stores its configuration data as well as like the users and that kind of thing that it has set up inside of databases within the system. So that's what's going on in these defaults. If I want to create a new database, I have to simply just say that I want to use that database. So I just say use test. I believe that changes my database to the test database. And then if I want to create a collection, I just start simply adding things to that collection. So to do that, I can just say db dot, I'm just going to say dot cars, because that's what the example I have. Then I'm just going to say insert one. I can say, and then just start typing out an object to put in there. So just type that. So this inserts one object into our database. If I do a find on there, I can say db dot find, or no, db cars dot find, and then if I just include empty brackets, that just is like the equivalent of doing select star and SQL. It's just anything and everything. So if I hit that, it'll give me back the one object that I have in my collection. So you can work with your database this way if you need to manually sort of change things. You don't want to necessarily do that programmatically. You can go in, you can delete databases, you can test out different queries that you're thinking about using in your applications. This is a good place to do that. Let's see, there is also this application that now comes with Mongo called Compass, which is good for connecting to a database and having a GUI that can kind of look at what documents you have. So if I hit connect, it should just connect to my local database. And so again, you can see the different databases that I have, admin, config, local, and one I just created test. So if I go and click on test, I can see cars. And I should be able to go see that, yeah, cars has this one entry in it. And you should be able to write different filters and queries in here, test them out. Yeah.
So when you did db.cars, so when you did the cars, that created the type of.
That created the collection. So yeah, I should show that. So if I type, so before I did show DBs, which show the DBs that I have, if I type show collections, it'll show the different collections that are inside of this database. So whenever I did db.cars.insert1.
That was a collection already created?
Yeah, so it automatically created the collection whenever I inserted one into it, basically. So, and this .cars is the name of the collection right here. So I didn't have to explicitly say create the collection.
Okay, yeah, that's awesome.
So, thanks, that's a good question.
And
Yeah.
the acknowledged true, does that just mean that your insert was successful?
Yes, that is the feedback that you get saying that, yes. And I think the inserted ID, this is the ID that it gave that object. So whenever you insert an object into the database, it automatically assigns it an ID, and so it gave that back here. And so if you look, whenever I did the query, this is the same object ID for that object that I just created right here. Is that clear? Are people kind of following what's going on? Yeah? All right. Yeah,
When you
Anthony?
use the use test, that means at the time you created the table, the name did the test, or you have the test, you wanted to test, use the test.
So when I typed use test, it was kind of like this operation. So when I said use test, this automatically created the database test because it didn't exist. And then it switched the context to using that database. So if I add or remove collections, it'll be to that particular database.
So
Yeah.
DB cars is inside test.
Yes. So DB cars is the collection inside of the database test.
Test.
But you, at the moment you created the test, where you use the use test, at the moment you created the table, the name is test.
Yeah, so when I typed use test, and it says switch to DB test, at that moment it created that database test. Yes, Anthony.
So, if I wanted to add, like, insert one into the cars collection, would I have to put DB dot in front of it each time?
Yes, you have to do DB dot cars. I don't know why it's just the syntax. Okay. Is there another question? I thought I saw another hand raised. Okay. So as I mentioned, there's this GUI tool that will help you look through your databases, so you don't have to remember all of the different queries and things if you're just trying to take a look at what's there. And you can take a look at what's in the other databases and collections as well. And I think it'll help you use some of the other features of Mongo as well. Which I think I have some slides on. Right, so Mongo has other features besides this. So somebody that's taken the database class, so Mongo supports indexing. Can someone explain to me quickly what an index is? You have to have covered this in a database class. Sure, I mean.
Index help us to search something faster rather than search entire data in a database. They kind of the collection of the something like the ID. You index the part of the whole data. When you want to search it, just search the index. It makes you faster to retrieve the data or search it something like that.
Right, so it's an additional data structure that the database maintains that helps you search on particular features of the elements within a particular collection. So typically with Mongo, the default index is that it has one set up for the IDs of objects, I believe, so that it can look up an object in like O of one time based on its ID using like a hash table type structure. However, we can think about other indexes if, say, we are thinking about like my car example, we could have an index based on year, which would speed up any kinds of queries that we would make off of year. So we could say, give me any car that is, made in the year after 1970. And the data structure would optimize that query. If you don't have an index, what the database basically has to do is it has to look at every single record, every single object in your collection, and make a check whether or not it should be returned in your query. And so basically the time becomes constant relative to the size of your database. The index helps you do it faster than that, basically. You do incur some overhead just because you have to maintain the index. So anytime you add a record to your database, it has to update that index to make sure that it is up to date. And it also requires extra space to store it. And so, you want to be careful with what indexes you create in order to sort of optimize performance. If you have an index on like every single one of like 50 different fields of objects in your collection, then it might take a lot more overhead to sort of maintain those indices as you go along. Additionally, Mongo does, it does now, I don't think it used to actually, but it does now support schema validation. Can someone just give a brief explanation of what a schema is? Orion, you're taking databases, right?
I took it last year.
Yeah. So what's the schema?
Is it is it when you is it like you can create like another instance of the database and use it to search?
No,
I don't
that's
remember.
usually like sharding or I can't think of other names for it. Yeah.
Schema is just particular structure of a database, particular
Sorry, say that again.
Oh.
schema is a structure of a database, a particular instance.
Right, so a schema specifies like what is valid data to be inside of a collection or a table inside of like an SQL database. So it specifies like what are the entries in a particular object. So the schema for like my example cars would be, you know, I have model, which is a string, I have make, which is a string, I have year, which is an integer, I have color, which is a string, or some other data structure, and you could specify. Basically, let's just make sure that you have a uniform set of objects within your collection. By default, Mongo doesn't enforce a schema, so you know I could have cars and candy bars and ice cream cones and pets and all sorts of things in one collection. It wouldn't necessarily be useful, but Mongo does let me do that. Yeah.
So it's like the one-to-one and one-to-many, the example of how they work with each other.
So that's like the different type of like relational relationships. You can have those in Mongo, and I'll have a slide about how that works here in a second. But yeah, I guess a schema would be part of specifying that. But typically, yeah, the schema is just sort of like the solid definition of like what the data inside of your database looks like, right? Inside of your collections. Okay. Additionally, Mongo support. Yes, I mean.
I'm sorry about that. For the schema, you said actually you show us the type of the data we have in the database, the string or integer or something like that, or something else.
Yeah, if you'll just hold on, I'm actually going to use schemas whenever I show how to use it with Node here in a few slides, so I'll just show how it works. But I do want to bring up what some of these other features are. So have people heard of like big data before? This is like a hot buzzword in computer science. So Mongo is probably not the #1 tool that you would want to use for it, but it does have some of the features that you would typically find in a big data type package. Typically, or specifically, it has aggregation tools and what is called MapReduce, which are basically tools for helping you process large data sets and like doing things like counting or making collections or grouping pieces of data together. You know, this can be useful if you want to run, if you want to understand like some sort of analytic or statistic about the data that's in your database. I'm not going to go into the particulars of those functionalities, but if you are wanting to do something like that, know that you can look at either aggregation or MapReduce functionality for Mongo, and that it can help you do those types of things. Additionally, Mongo has support for horizontal scaling, meaning that we split our databases over many different servers, and we have pieces of the database managed and stored on those different servers, and then we can make requests to those like pools of servers. Basically, this is like we have very large data sets. Using sharding is what it's called as a technique is useful for having those very large data sets distributed over like several database servers. We're not gonna do any of that in this class unless some of you are like generating billions of records. But do know that is something that you can do. All right. And so what Orion was bringing up before about the relational databasing aspects, something that you can do with Mongo is basically you can reference objects in other collections with their IDs and different documents. So if I have a collection of users, all of which have an ID, and then I have other documents that have that are either maybe owned by that user or are shared with those users, I can have references to those IDs inside of these models or inside of these objects. And Mongo does have calls and tools, and the package I'm getting ready to show you has tools for populating those. And so you can make a query that will automatically populate this with the actual object, so you don't have to make another query, and it'll sort of make those joins and help you do those instantiate those like relational structures. So know that is also available with Mongo. It's a little bit more of a complicated thing to do, but if you I'm
So,
not yeah.
Professor, so that's the same user, but we're just
Yeah, so
in a
it's-
different like
Yeah,
tables.
so instead of like storing like the whole like user like sub object within this object, I just store a reference ID to that user, and then I believe it's called lookup or populate is the it's like an aggregation tool that you can use with Mongo that'll like automatically populate in those. It'll replace this ID whenever you make a query. It'll replace this ID with the user object, so you don't have to go look it up again. It'll just do it. It'll do that lookup for you and put it in the data that it's returning, and then send it back to you.
And then those two on the right, so the underscore ID, those would be uniques.
So
Like
this is-
ID2 and ID3, those are.
So these are the IDs for like this document. This would be the ID for this contact document. This would be the ID for this like access document. But this user underscore ID is referencing the underscore ID for this user document, or this user here. So, does that answer your question?
Yeah, so it just generates a new ID for the other tables.
So,
Above.
so every document that's in any table or in any collection, as they're called in Mongo, has their own ID that's automatically generated at the time that the object is created. These objects though are just a way to reference objects in other collections, or they could be the same collection. But yeah, these IDs are just unique and they're created automatically by the database.
That means we can access the contact document when I use the IT user document without checking the contact document. Yes. Because it's referenced to the contact.
So, I should have made a slide about this. So, basically what happens is if I look up this access document, I can add the parameter to populate this document or this particular field within this document. And whenever I pull this access document outside of its collection, then I can tell Mongo to go and to look up the user that it's associated with out of the user collection using the ID that I have stored here, and then it will populate that user object into my access document automatically. And so it's just a way of specifying these relationships without having to make multiple queries to the server, basically. So I mean, one thing I could do is I could do a query to find this access document. I pull it down, I look at it, I see that it has this user, and then I make another query to the server that would tell me, using that ID to say, look up the user that's associated with this access document, and then it would bring that back. Each time I do that, I have to do like a back and forth communication with the server. But Mongo has tools that just allow you to tell it to do that automatically in one request, so I don't have to keep making multiple ones. Let me just look up how to do that real quick. I'm gonna actually show the next part of this, and I can come back to this if people still have questions about it at the end. All right, so great. We have a Mongo database with some data in it, collections. So how do we actually use that from Node? The primary way. The most common way is to use this package called Mongoose. There is also a more raw Mongo package that's available for Node, which you can use. But Mongoose provides some extra functionality. The first is that it provides like object modeling, and so it handles some of the marshalling in and out of the BSON data structures into JavaScript objects. It also provides some support for schema-ing and other functionality. Let's see, so yeah, it supports most of the CRUD operations, it supports schema-ing, and all the other functionalities like the aggregation as well as the MapReduce lookups. So it can do those things for you. I'm gonna run through a quick example of how you actually use this. Okay, so when you want to use it, you need to npm install save mongoose. It'll pull all the dependencies that you want. Okay, so the baseline thing that is most often used with Mongoose is setting up schemas. So as I was mentioning before, I can set up a car schema for which has a make, model, year, color with string, number, and string, which basically just says to make sure that the data I put inside of this collection has these data types. I can also add static functions to these schemas, which basically provide functionality for saving the queries that I would want to do on that particular collection. So if I wanted to find all the cars in my collection, I can set up this static function for this particular schema that is just simply the select.star or this.find, which will find all of them. But I could do other things like find all, doing a query by year, doing a query by make or model, those kinds of things in here. Right, so once I have the schema set up, oh yeah, go ahead.
I wanted to ask, so if you didn't do the like schema, does that mean that you could just, like, whenever you put stuff in your database, it could be like any number of attributes in any type?
Yes.
Okay.
And I think you could probably still do that with Mongoose. I think it just puts a little extra layer of structure on top of it so that it's a little bit easier to work with. So you know what you're expecting. In terms of the other pieces of data, I think it will populate those fields if they're there. It just won't do the validation to make sure that those fields exist if you're making new things.
So if you were to put like a new car object in with like an extra attribute for like whatever, it just it would restrict the types of all the other attributes except for the extra one? Or?
I think it would still put in the extra attribute. We can test that here in a second. but I think it will verify to make sure that all of these attributes are there. It might also you can also specify like default values for these things. So once you have a schema, you instantiate it as what's called a model. This is basically what ties the schema to an actual collection. So it does something that's a little bit, I don't know, intelligent maybe in that. So whenever you instantiate the model, you give it this string, which is the name for that type model, but actually this is specifying what collection you want this in. So it automatically lowercases this and adds an S to figure out what the collection is, and then we specify what the schema is that we're using for that particular collection. So once we have that, we can do things like we can create a new car with, so we have some initial data here. We can instantiate our, oh, this is not right. This should be, so we can instantiate the model with some of our data, which then gives us a document. That document does not yet exist in the database, it just exists on the server. To actually save it in the database, we have to call .save. So mycar.save, and then I can give it a callback, which basically just handles if there's an error saving it to the database, because this is a network operation. Typically, databases are on, it can be on another computer across the world, and so whenever we hit save, something can go wrong there in the middle, and so we have a callback here just in case that happens. Alternatively, you can use the promise notation that I mentioned before. So we have .then and .catch. If that's clear, people remember bringing up promises and how those work? All right. Right, and so I mentioned the static functions before. So if I have this static function in my schema, and I instantiate the model app of it, I can call, car model, list all cars. That'll send this query from this this function to the server. It'll take the responses and it will, again, this is actually returning a promise because again, it's a network operation. So .then, I'm missing some curly brackets here. And then you could actually output this collection of cars here. So you could say, so just to give you an idea how we can incorporate this into an actual running application, I'm going to do a walkthrough from where we can take data that's input in a form on someone's web page. It takes that data, it sends it through a post request to the server parses that data, it puts it into a model for Mongoose, and then it will save it to the database, and then we can access those things. So let's run through that example. Okay, so this is loosely based off of one of my previous examples with cars and garage. This is the index file for our Node application. Notice we're including Express and Mongoose. We're connecting to Mongoose. So this is the default string that you'll want to use. This is connecting to a Mongo server that's on the same computer at 27017, which is the default port. And then I'm connecting to the test database with this slash here. And I have like a .catch over here for if something goes wrong. It's all just one line. That's ugly. Don't pay attention to that. All right. So what am I doing here? So I'm instantiating the car model, but I actually have this in a different module that I'm importing. So if you remember, I mentioned how to create modules before. Where is that? So I have this in /model/car_s or car.js. So again, I'm requiring mongoose. I'm instantiating the schema as mongoose.schema with string, number string, yada yada. Same example. Have the static that I mentioned before that finds all my cars. And I instantiate the model in the car collection, and then I'm returning car model and the model exports. So if you remember before with modules, anything that I put in module.exports gets sent back to the require function for that module. So if I go back to index, that model is what's coming back here in this module. This is some of that middleware and that I've been discussing before with using EJS for using the templating. This is URL encoded is for parsing URL encoded HTTP request parameters. JSON is for JSON requests, although I don't think I'm actually using that here. Okay, so I'm supporting this form get, which basically just returns a page with a form on it, which I have as an EJS template here. Not that it needs to be, but basically this is just a form that has 4 entries for make, model, year, and color. Okay, and then if I get garage, so this is where we start doing some database work here. So if I call garage, basically what I look up first is I do car model list all cars. So it hits the database, it prints out all the cars that are in that database, and it returns it here as this this car data structure. Which will just be the equivalent to an array of the JavaScript objects that are represented in that particular collection. So I get that. And if you remember from before with the templating, I'm saying I want to render my garage page, and I'm sending it this data cars.cars, so it's putting the cars data structure inside of this value cars for this data object here. And if you'll recall, basically I'm just looping through these data structures in the I'm looping through all the cars and cars, and then outputting them. So it's using that data that I put into it from the GET request. Okay, and then I have this functionality here, which handles the post request coming from the form. So basically, that data that I enter in the form gets parsed by Express. It gets put in rec.body.car, and so I instantiate a new car model with that data, and then I save it to the database. And so I'm just handling the success and failure state here with these promises. Okay, so let's run this and see how that looks. need to install these npm packages. Because I use .save whenever I install them the first time, I can just hit npm install. So it's just automatically installing all my packages. All right, so there's some error code here, but it's just warning about deprecations. Everything is generally fine. Okay, so what I'm gonna do, for better or worse, is I'm gonna put a breakpoint here. So this is on the post request for whenever I'm getting a car that's coming in. So if I do localhost 3000, and then is it form? Okay, so I have this form that I can fill out, so I'll go and fill it out. So Toyota 6. Okay, so if I fill out this form, when I hit submit, it's going to send a post request to my server. And voila, I hit this breakpoint. So if I step over this, it outputs the data that's in that car object. I create a new car model, and then I go ahead and hit save. And it's sent back, add a new car to the database. If I go over here, hit find again, you'll see that it added this Toyota 4Runner object to my cars database, which again I can also see in command line. So I can do db.find. So now I have both the Mustang and the 4Runner object inside my database. Yep.
What's the underscore?
So the underscore v, I had to look this up too. Evidently Mongoose automatically adds that as like a versioning number. So if you like update that object, it'll increment that number. So it's like a way that it keeps track of the version for that object. So just a little bit of extra added noise. Okay. So that's how you can add something to your database. Now say if I wanted to look at everything in the database, I can type garage. Let me actually put in a breakpoint here. So I'm going to put a breakpoint that should come back here after I've already made my query to the database. So I come in and I make a GET request for garage. I automatically try to do a list all cars, which does a select star, basically, find all of the objects within my collection, and then responds with cars. So I'm going to respond break here. So I can see that. So trying to bring this up. So I've hit a breakpoint here. If I look at cars, basically I have two objects. There's a little bit of extra noise just because it is these Mongoose objects, but I can see red Ford Mustang 1965 and the first object. The second one I can see it's the black 4Runner. So if I go ahead and hit continue, it'll render that page and it'll output all of the objects that I have in the collection. So this is sort of like a full cycle to and from the database. You can get more complicated things going here for different types of queries, but generally you're just going to be like saving and retrieving documents. Vincent, you were asking about if I add like a different value to my object, whether or not that would get saved. I can just
Yeah.
test that real quick. So let's see, post. So I'm gonna say, like, I'm just gonna add, whoop, not that. Body dot car dot, I'm gonna say like dot owner gets bill. So that I'm just modifying this request as it comes in. Let's just restart all of this. So if we go back to form, okay, actually, I want a breakpoint here, so can submit. So yeah, I put that data in there. Let's step over. So it has the owner in there. I'll just hit continue. Let's go see if I look at the database. Oh, did something happen? Okay. So no, it doesn't look like it added that extra data. So I think if you are working with Mongoose, it'll just only use the data that's in the schema. It looks like. So yeah, I put owner in, but it didn't show up in the database when I saved it. So. All right. So that's the demo and the general introduction. People have ideas about or questions about what is going on here or why this would be useful or yeah.
I wanted to ask, like, what are the advantages of using like MongoDB over like SQL or something? Is it because it's close to JSON or?
That is one of the advantages. The other would be that you can sort of have arbitrarily complex data structures, whereas SQL is pretty rigid. So the structure of your objects can change quite a bit with Mongo, whereas with SQL it's pretty hard and fast, as understanding. So yes, there's that. And generally it's just very easy to work with in this kind of setting because it's very simple to get it in and out of JavaScript. So that's another advantage. Any other questions? So what kind of data would we potentially be storing in something like this?
You could do like user data, like usernames.
Yeah, you could use usernames. That's definitely probably in 95% of web applications, those usernames. You could have, yeah, if you're having like Google Docs, you could have all sorts of metadata like the owner, time created for you can have like representations of the documents, the text that's in those documents. What about with your games? What kind of data could you be sticking in there?
State.
States, you could store a game state in there, so you could take the data structures that you're using to store your game data set. You could just throw that right in the database.
Scores.
You could keep scores.
Would be the unique players
yeah, you can keep track of what players and like game instances those players are in. So yeah, the possibilities are endless. This is very good for yeah, keeping track of data, and something to keep in mind is a lot of like right now with your games, and you're making them multiplayer across the network, and I'm just expecting you to use data structures like on the server in memory, right? And so if your server crashes, that all just like disappears. Databases are very good for like keeping persistent data. If we start to think about scaling out our applications, so often the best way to do that is to start having like many instances of our server running on different machines. And so how do you share the data between those machines? Well, databases are a really good way of doing that. Something like Mongo, you can have like 50 different simultaneous clients connected to it, and they can all be like hitting it to get data, to save data. Yeah.
Does Mongo have a service to keep your database running?
Sorry?
Does Mongo, do we have a service to keep your database running, like, so like if you have.
So yeah, so it's usually run as a service that like just stays up.
Okay.
And it keeps like a port open that you can connect to. You don't have to like tell it to start and stop. It usually just is on. Once you've installed it as a service, you can start and stop the service, but if you're running like a web application, you would just keep it on, basically. Some of the free services out there for Mongo probably like automatically like spin your database down when you're not using it, and then spin it back up when you are, which might incur some lag, but you're getting it for free. I think one of the next topics I'm going to cover is I'm going to talk about how you can sort of scale out a Node application, how you can have multiple ones running, and we can take a look at like how you do some data sharing in that instance, between the different Node things that are going at the same time. But yeah, with databases you could also have, so you could have like your web, your main like website Node application running that's accessing the database, but you could also have some sort of utility that you write that's like analyzing the data and like making reports or something like that that could be hitting it at the same time. There's a lot of different things that you can do with this. So if there are no more questions, that's all I have to talk about today. But I'll hang around here for a few minutes afterwards if you want to talk about your games or this or anything else. So thanks.
Is it okay if I redo my game for the future projects? Like, it's fine what I submitted, but I don't want to do